Let's talk about lines. Now, in this chapter, we're going to talk about line in general, and we're going to talk um, a lot of related concept with lines. Now, when we say line in this chapter, we are only going to restrict ourselves for dealing with straight line only, right? Straight line only. So we're not going to uh, when we say lines in algebra, they usually mean a straight line. So we'll talk about lines. All right. So there are two important related concept with line, and they are, one is slope and another one is intercept. So what is slope and what is intercept? Well, slope, well, what do you think? What do you think its slope is? Slope describe stiffness of a line. You know, some line increase like this. Well, let's pretend that these are all straight lines. Some lines increase like this. Some lines not increase, not decrease. Some lines even decrease. So slope is numerical measure, meaning slope is a number that represent the stiffness, whether it's going up, if it's increasing, how fast it's increasing, if it's going down, how fast it's going down. Slope is the number that describe how fast or how slow that line um, increase or decrease. And intercept, I'm just giving you an overview. Intercept is, when you have a straight line, when you have x and y axis. Intercept is this point and this point. The point where the line is crossing either y-axis or the axis, right? So these 2 points are what we call intercept. So that's a general overview. Let's talk a little bit in detail about slope. Now, when we say slope, we usually use letter M for slope. So when you see M from now on, you can assume that they are talking about slope. So let's say a line goes like this, and we need 2 reference points. Let's say this point as x1, y1 point. Let's say this point as x2, y2 point. So we have these 2 points. So when we try to figure out how fast it increase or decrease, we use this formula. So m is y2 minus y1 and x2 minus x1, this formula. Then I want you to actually memorize this formula. And we also need this condition. x1 cannot be equal to x2, right? So why do we need this condition? Well, what do you think? What will happen if x1 and x2 are equal? Well, then this denominator is going to go to 0, and we do not want that. So we need to have this condition, right? And you can also understand this as change in y over, let me put it up a little bit, change in x. So you can, I mean, these two are the same thing. I mean, this and this are the same thing. You try to see how much y changed. I mean, that's why we did y2 minus y1. They tried to see how much y changed, right? If you just draw this triangle like this would be how much y changed, and this would be how much x changed, right? So how much y changed with respect to how much x changed. Well, sometimes they even use this small triangle delta x. So this small triangle actually referring to a Greek letter, and it's called delta, and that's usually for difference or distance, right? So difference in y, which is same thing as change in y, over difference in x. You may seen something like this as well. Rise over run. So when they say rise, means how much you rise. Run is talking about this distance, the x distance, right? So how much x changed and how much y changed. Put that into a fraction or the ratio form. That's slope. And what I want you to memorize is all this concept. I want you to understand all this concept, but I want you to memorize this formula. This formula, just right there. So, just simple example. Let's say find the slope of the line passing 2 points. Let's say 1 and 2 and 5, -3. Something like this. -3. So how do we find this? All we need to do actually is, if you remember this formula, put that in that formula, right? So let's say this is our x1, this is y1, this is x2, this is y2. So m slope that we want is y2 minus y1, x2 minus x1. I mean, easy as this, -5 over 4. You can leave it like that, or if you want, you can pull this negative to the front, write it like this. That's our slope, right? That's our slope. Okay. I guess that's not too bad, right? That's not too bad. So that's a slope, and that's the formula that we need to memorize. Okay, and let's talk also several different forms of line equation, or should we say the linear equation, right? First, general form. General form of line equation looks like this. Ax plus by equals c. ABC is just a number, right? ABC is just a number. So, example, something like 2x minus 4y equal 10. Something like this. A, B, C is just a number. So this is what we call the general form. Another form that I want you to understand is, and also memorize, is what's called point-slope form. Point-slope form. Now, point-slope form is one of the most popular and most often used form. When do we use this? We use this form when we have a point and slope. When we have a point and slope, we use point-slope form. I mean, that kind of makes sense. So the point here is going to be, let's say, x1, y1. Now, in the actual case, this x1, y1 is going to be actual number. And slope is m, right? We use m for slope. Right? We use m for slope. So, what's the actual form? Actual form looks like this. Y minus y1 equal m times x minus x1. Okay, x1. So, this x1, y1, and m, these are going to be actual number at the end. Actual number at the end. Actual number at the end. And this x and y, these are not going to be replaced. These are just a fixed x and y, right? These are just a fixed x and y. So, I mean, the question example could be something like this. Example, find find an equation of the line with slope 4 and containing the point 1 and 2. Write the equation in the general form. Okay, so we need to find a line equation that has slope 4 and passing this point, and we need to put our final answer in the general form. All right, so when we have a point, when we have a point and slope, what form should we use? Of course, it's going to be point slope form, right? So, excuse me. Let me rewrite the actual formula. Formula was y minus y1 m x minus x1, right? So our equation is going to be y minus y1, which is 2, equal m for slope, right? X minus x1, 1, right there. Okay, so this is the equation that describes a line that's passing this point and has slope of 4. Now we need to put that into the general form, right? What was general form? The general form was ax plus by equals c, right? Meaning x and y has to be in the left hand side and right hand side should be the number only. So let's simplify this a little bit. Y minus 2 equal, let's distribute this 4, so it'll be 4x minus 4, right? I'm just multiplying this 4 inside. So I'm going to move this here and move this number there. So negative 4x, because when we move a term across equal sign, the sign change, right? This positive 4x become negative 4x. Plus y, because that's a plus y, right? Equal. We have negative 4, which is this negative 4. And when we move this negative 2, become positive 2. So our final answer should be negative 4x plus y equal negative 2. Just like that. All right. Now let's talk about slope-intercept form. Right? So this is yet another form. We talked about the general form. We talked about the slope-intercept form. And the last form that I want you to understand is what's called slope-intercept form. Slope-intercept form. So slope-intercept form looks like this. Y equal mx plus b. All right. So this m right here is, as you guessed, this would be the slope. What about this b then? This b is y-intercept. Right? This b is y-intercept. So, I mean, a nice thing about this slope-intercept form is that, you know, when you see the actual equation, then you can almost guess the graph of that equation. You can almost guess what it looks like. You know, for example, let's say you have y equal 2x plus 3, right? And I'm trying to guess what it looks like, right? I'm trying to figure out what the graph of this equation looks like. I know that it has slope of 2 and it has y-intercept as positive 3. What does that supposed to mean? Well, let me go straight down. Let's say this 3 is a y-intercept. So let's say if it's 1, 2, 3, I know that this line that I'm looking for is going to pass this point. right? It makes sense because that's what y-intercept means because it's in that form. You know, just going back to this form, what we mean by this form is that we shouldn't have anything except just the y in the left hand side. There shouldn't be any number in front. It should be just nice y only, and then we should have a number in front of x, and we have a actual number which is going to be the y-intercept. So just by looking at this, I can see that it's going to pass this point. Now, what about this slope 2? Well, you can think of this 2 as 2 over 1. Right? You can think of this 2 as 2 over 1. And remember that one of the definition of slope, what was this top number? This was change in y. What about this, the bottom number? This was change in x. So while y changed 2 unit, x is going to change 1 unit. So when we say y change positive 2 unit, that means from here it's going to go 1 and 2 up. So at the moment that's going to be 5 there. That's y change. What about this x change? X change as 1 unit, then move 1 to the right, and we end up here. And we started from here, we end up there. So now we have a line that goes like this. Wow, I like that line. We draw it. It should pass this point. Let me change color. Pass this point and pass this point. So line should go like this. And that's the graph of this equation as well, right? So once you have this slope intercept form, then you can um, pretty much graph the equation. You can pretty much graph the equation. Okay. All right. So we went through 3 different types of form, and we talked about uh, basic general related concept with those forms. Okay.